Okay, so on this question, it says you are conducting a study to see if the proportion of voters who prefer the Democratic candidate is significantly larger than 73% at a level of significance alpha 0.01. According to your sample, 76.6234% of 77 potential voters prefer the Democratic candidate. Huh. Okay, so what's going on here? So first off, suppose you're doing a polling. You're trying to figure out ahead of time how many people prefer the Democratic candidate, and specifically, if it's significantly larger than 73%. Well, you did a little sample of 77 potential voters, and you found that 76.6234% of them do prefer the Democratic candidate. So, well, that's higher than 73, isn't it? So isn't the answer just yes? I mean, what's all this stuff? Are you kidding me? This is busy work? I mean, what's going on here? Right? We're saying you're conducting a study to see if it's significantly larger than 73. You did your sample, 76.6234. That's larger than 73 for the 77 voters you asked. Yeah, the answer is yes. Done, right? No, there's a little more to the story. Why? Well, because the main problem is these 77 voters could have been a lucky sample. You see, that's the problem. That's real life. I mean, they're testing a new treatment for cancer, right? You give it to 77 people and the new treatment for skin cancer seems to do better than the old one. Is it really better? Maybe you should test it on some more people, because maybe if you only did 10 people or 20 or 77 even, maybe they were a lucky group, meaning they were already more healthy by random, lucky or unlucky, however you say it, sample. You just happened to grab a group of 77 and most of them were more healthy than most people. By random luck, you happen to get a healthier group. And so they did better with the new treatment, not because the new treatment is really, truly better, but because they were just healthier people. And if we, make a conclusion based on that study with just 77 people, and then for the next decade, 10 years, we give everybody in the world this new treatment for skin cancer, and it's actually worse, that's a big mistake, huh? So you see, that's why we do hypothesis tests. We always have to worry about luck. What about luck? What about the fact that you could just get a random lucky sample? That's the problem. That's always what we're worried about in real life. Medicine, government, sociology, psychology, business, real life in our society. This is important. How do you know when data is strong enough to where it's beyond reasonable doubt, as they say in law, in a court of law, right? That's what we need. We need to make sure the evidence is so strong that there's almost no chance of luck, right? Instead of 77 people, we should talk to 700 people. Give the new cancer treatment to 700 people. And if they're doing better, then we're pretty darn sure it's not just lucky group. You can't get lucky that many times. I mean, you could, but it's such a low chance that we're very, very sure the new treatment is really better. You get the idea? That's always what we're doing. That's why the answer is not a simple yes. There's always, what about luck? Maybe it could have just been a lucky group of 77 that happened to just like the Democratic candidate better by lucky random sample. What's the chances of that? That's called the p-value. That's exactly what the p-value is, the probability of luck. And that's why we do the whole study. All right, let's get into it. For this study, we should use what? What is it saying there? What should we use? Well, let's go to the notes and we will see. So I'm going to go to the notes here with you. And so if you go to the exam notes, in fact, actually not that part. Let me grab this part. Right, no, not that part, this part. No, still struggling. There it is. No, sorry, did I have it actually there? No, I did not. Sorry, I'm not finding it where I hope to find it. Okay, I think I got it. Yeah. There it is. Beautiful. Okay, that's what I wanted. So looking at the notes with you. So these are the exam 3 notes. My iPad will not let me go for There we go. Thank you, iPad. All right, these are the exam 3 notes. You want to print these out. These are your lifeblood during the test. You need these. All right. So hypothesis using the calculator, 83, 84, it doesn't matter. What do? Do we have a percentage or a mean? Mean is average, and you have 2 kinds, no data, data. Which kind of question do we have? Well, it's a hypothesis test. Yeah, it's a proportion, percentage, huh? And then they're giving us percentages like 73% and 70. Yeah, it's all about percentage, isn't it? For sure. So this is a percentage. We're right up here, aren't we? So we're going to do what? 1 prop Z test. 1 prop Z test. All right, so we come on down here and we go, okay, 1 prop Z test. So let's do that. So I'm going to go to the TI. Oh, wait a minute. And that means this is a Z test. Sorry, we're answering that first question. 1 prop Z test. So it's a Z test there. All right, and we got to write the, so before we go to the calculator, let me hold off on that. We got to do the HO and the H1. What's the HO? Well, what's important is to write the claim. You always want to write the claim. What's being claimed? You're trying to see if the proportion of voters who prefer the Democratic candidate is larger than 73. So you're claiming that the proportion is greater than 0.73, larger, right? Larger, that's what's being claimed. So what do we put on HO? P, and HO is always equal, isn't it? Let me write that, always. Always. And that's going to be 0.73. And this is going to be P greater than 0.73. Why? Because that's the claim. Larger, larger, greater. Now, if yours said smaller, then you would go less, right? So larger, bigger would be greater, smaller would be less. If it said different, then that's not equal. If something's different, it's not equal, right? All right, so there's that. And now let's go on. Now we got to determine the test. I'm on part C, the test statistic. How do we do that? That comes from the calculator. So now we're going to go to the TI calculator, like the note said. Go to the TI 8384, choose stat, go across twice to tests, go down to the 1 prop Z as it told us, which is number 5. 1 prop Z test. 1 prop Z test, that's what it says right here in the notes for us. 1 prop Z test. All right. And so when you do that on your calculator, it's going to give you P0 and X and N. And it's going to say proposition. It's going to have, it's going to have not equals, less than, greater than, and then calculate. Okay, so what are we going to do? Well, the P0 is always 0.7. It's always the number right here from H0, right? So P0 comes from H0. It's just a number right there. That'd be 7.3. Okay, now what is X? What is N? All right, that's the trick here. That's the trick I want to show you about. That's what's a little bit different here. On a lot of these problems for X and N, they'll say, so they asked 77 potential. They'll say, we asked, here's what they do a lot of these for this. So we asked 77 and, 61 prefer the Democratic candidate, right? They'll just give us the number. And in that case, the X would be 61 and the N would be 77. That's what they usually do, or about half the time. About half the time, they just give us those numbers straight out. They just say, hey, we surveyed 77 people, 61 of them preferred the Democratic candidate. So then you remember the X is always smaller than the N. So you'd put the 61 here, you'd be saying 61 out of 77 preferred the Democratic candidate. Well, in this case, the 77 is right. We do put the 77. That is the N. That is the total right here. This is N. The N is definitely the 77. That's the total number of people we surveyed, we asked. But they're not giving us the X, are they? They're not telling us how many actually said, yes, I prefer the Democratic candidate? But they are telling us right here, the percentage. 76.6234% of the 77 prefer the Democratic candidate. Okay, so what do you do with that? Well, that means when they give that to you, you got to figure that out for yourself. So let me get rid of this stuff and do that right here. I'm going to do it right here. And I'm going to say, I'm going to make that a decimal first off. Point. Well, let me write this first off. Of the 77. I just took this of 77, moved it next to it. Right. And then so let's make that a decimal. 0.76624. Of. What is of always in math?
Is it times, like the way we did the other one?
Exactly. Good. It's times. Yeah, of is times. So 76.6234, change it to a decimal, meaning move the decimal back 2 places, of times 77, and hit the buttons on your calculator. So I'm going to do that same thing right now. 0.76624 times 77. Now I'm getting 59.00018. And now you round it. You round to 59. And that's your x right there. Now, how do you know you're supposed to round? Why don't we just put in the whole number? Well, think about it for a second. These are actual people. Remember, try to keep one foot in reality whenever you're doing these problems. We actually asked 77 people. We literally went up to 77 different people and said, hey, who do you prefer? You know, and 76.6234% of them, of those 77, said they prefer the Democratic candidate. That means it can't be 59.00018. It's people. You can't have part of a person. So it's 59 people. It's 59 of the 77 actually prefer the Democratic candidate. It's got to be a whole number because it's people. You can't have part of a person. Right? So that's how we know we're supposed to round it. We're supposed to round it. And so those instructions, let me show you where those instructions are. I think I'll try to, I'm going to have to add them to that section because they're not there right now. But here's where they are at. They're on the confidence interval section. Right here, X is the number asked for. This must be a whole number, not a decimal. If you're given a percent, like 23% of 80, then multiply by that and round to 18. So I put them in the confidence section, but it's the same thing here. When you're figuring your X on the one prop Z, when you're figuring your X, it must be a whole number. You can't put in a decimal. The calculator will choke. If you're given a percentage like 23% of 80, then multiply the decimal times 80, 18 by 4, and then round it is what you got to do. So there's the instructions from the notes. I'll try to put them right on the confidence interval. They're not there right now. I'll try to add them in. Anyway, so this comes out straight 59. All right, so there we go. Now we go back to business. What are we supposed to do? Ours is a greater than, so I'll choose the great, mine is, and then calculate. Hit the button, get the answer. So let me show that on the calculator, on my calculator on my screen now. There it is. Turn this on and clear the screen and clear that. All right, here we go. I'm going to go, oh, first off, I'm going to calculate that number. Well, I already did that. So I'm going to go to stat, go over to over to test, down to one prop Z test, which is number 5. Hit enter. All right, P0. What was P0? 0.73. 0.73. Enter. And the X. Now here's where the X was 15. Let me purposely put in a decimal and show you how that'll wreck it. If you put in 0.00018, isn't that what mine was? Yeah. Watch, it won't work. And then my N was what, 59? No, 77. And then come down here. I'm supposed to choose greater than. Go over to the greater than and hit enter. So it's on the greater than. Go down to K. Watch, it's going to have an error because that X cannot be a decimal. You can't have part of a person. It's 59 people out of 77. You can't be 59.00018 people. What's that? Hit calculate, error, domain. I don't want that to happen to you during the exam. So that's why I'm telling you about it right now. So you quit, go back, do it again. You go, oh yeah, that's got to be a whole number. Calculator knows that's got to be a whole number. So you go back down and you go, oh, okay, I'll just make this 59. Enter, right? It's got to be a whole number of people. So now calculate. There we go. There's our results. There's my Z, there's my P. So there's the values I want to use. So let me go back now to my iPad, and we'll finish it up. All right. Okay, so now we're going to put in the P and the Z. Let me put it in real quick. Okay, so I'm going to come down here now. The test statistic is the T, or I'm sorry, the Z, which is, and they want 3 places, 0.716. And then the p-value, they want 4 places, 0.2369. 2369 is my P. And then on E, we're supposed to determine if how the p-value compares to the alpha level. All right, so let's do that. So I've got 0.2369 is my p-value. And how does that compare to alpha? Let me go grab alpha. Where's alpha? Alpha. Oh, right there. Alpha. So 0.01. It's alpha. All right. Well, that's pretty easy, huh? My P is greater. My P is way greater. So, all right. So my P-value is greater. So I'll put in greater here, greater. And then what does that mean we conclude? Now, do you remember how the conclusion goes? Let me write it over. Here's the big saying we always focus on. The main and most important saying for a hypothesis test. If the P is low, then the HO must go. And by go, we mean go away. It's meant to rhyme, so you can remember it easily. If the P is low, the null must go. If the P is low, the HO must go away, that is. So now, is mine low? Is that the case with mine? Is mine low? No, mine's greater. Mine's greater. So mine is not low, so the HO must not go away, right? Because mine is greater. So in my particular, so if the P was low, then the null would go away, but mine's not low, mine's greater. So if the P is not low, it's greater, then the HO must not go away. Okay, so what does that mean? That means I'm going to keep the HO. It's not going to go away. I'm going to fail to reject. And that's how we say it. We don't say accept, right? Right here, you're going to choose fail to reject. At least on mine, I'm going to fail to reject the null. I'm keeping the null. It must not go away. Now, if it was the other way, if my P was less here, if I had a number like 0.00010, something lower than 01, my P was less, then my P would be lower. And if my P was low, the null must go away, which means bye-bye null, cross out the null, reject. I would reject the null. But I'm keeping the null in this case, keeping the null. So now what does that mean? Well, remember what we always are supposed to write next to the null. Next to the null, you always want to write, let me go up here and do it. Weak evidence. You're always, the null always has weak evidence, and the H1 always has strong evidence, like a court of law. You assume the null is true. So if the evidence is weak, you stick with the null. You only go with H1 if evidence is strong beyond a reasonable doubt. Okay, so evidence is weak. So I am going with the null, right? I'm coming on down here. I'm keeping the null. So what does the null say? Let me write it out. The null says that the P equals 0.73, right? And evidence is weak. Are you with me? So the reason I'm doing this is because it specifically says on this question, or my specific conclusion was, right, my P was greater, it was not low, so the null must not go away. So I'm keeping the null. So here's the null. That's what I'm keeping. Remember, in the end, we're always trying to decide, am I going with HO or am I going with H1? Which one is it? HO or H1? Who am I keeping? Who am I believing? Which attorney do I think has the evidence? The data points to which attorney. And in this case, I'm going with HO. So I'm writing out what HO says. What does he say? The percentage equals 0.73 and the evidence is weak. All right. Well, and weak is another way of saying insignificant, not significant, right? Significant means weighty, big, important. So if evidence is weak, it's insignificant. It's not significant. All right, let's come on down here then and do G. So what does G say? Well, look for the keywords. Is significantly larger than 73? Is that what we concluded? Is larger? No. We concluded equals. No, that's wrong. Is not larger. Yes. Is not larger. Yes. So both those are right. We concluded it's not larger. It's equal, right? Over here, I've got P equal to 0.73. So not larger. Yeah, not larger. That's right. Not larger. Not larger. Okay, well, then what else? What else is there to this problem? Sufficient evidence, not sufficient evidence. Which one do we have? Weak, insufficient, or not sufficient. Same thing. There's not enough evidence, not sufficient evidence. So we're going with this one. Sufficient is wrong. So there's our conclusion. Right now, last two questions are kind of tricky. They're asking us to interpret the p-value and interpret the level of significance. Okay, well, let's be clear on this. This is, I know, not easy. What is a p-value? So I'm going to come down here and do part H. What is a p-value? Well, if you go to the notes, it's in the notes, you'll see that basically what I write out for what a p-value is, it's first off, it's the probability or percent chance. So it's the chance of something happening. Of what? Of number one, if the HO is true. Two, that we would get the results we got. A little squiggly there. That we would get the results we got by luck, by random unlucky. Let's just say unluckiness. Unluck, is that a word? Whatever, good enough. Random luck, okay? So that's what the p-value is. It's the probability that actually the H0 is true and we just got these results by luck, right? Remember I talked about that. I said, like you have a new cancer treatment, right? And maybe the new cancer treatment is really not any better. Maybe it's worse than the old treatment. And you give it to 10 people and they seem to do better. And so you start thinking, oh, I think this new treatment's better. Well, you just got a lucky sample, or unlucky as the case may be, that was healthier people. And so, yeah, they did better. So they made it look like the new treatment was better, but maybe it was just a lucky sample. And really the new treatment is worse. And you better not better not make it the new deal for the next 10 years. You're going to mess up a lot of people. So you got to make sure that it's not just luck, right? Or at least the chance of luck is super low, because there's always the chance of luck. I could get struck by lightning 3 times today. It's possible, but it's very, very unlikely. I'd be willing to bet a lot of money that I'm not going to be struck by lightning 3 times today, or you too, right? So there's always a chance of luck, but we want to make it super low so that we have strong confidence. Well, that's what the p-value, it's a probability of luck. It's a probability of luck. That's a nice way to summarize it. It's a probability, probability or percent chance, I'm going to say, or percent chance of luck, meaning specifically, if H0 is true, that we would get these results that we got by random luck. Okay, well, let's read through now and find out which one of those really says that. But this first one, if the population proportion of voters who prefer the Democratic candidate really is 73%, is that what the HO says? Was that the HO? Yeah, that's the HO. And that's what this says. If the HO is true, right? The p-value says if the HO is true, what's the chance we would get these results by lot? Is that what they're saying? That's what they're saying. The first one's looking good. That if, let's say if HO true, right? If it's really 73%, that's what HO said. It's really equal to 73, right? Up here, HO said it's really equal to 73, is equal 0.73. If that's really true, and if another 77 voters were surveyed, that there would be a 23.69%. No, what's that? What's that 23%? That's the p-value. That's what our p-value is right here, 2369. That's it. P-value is 0.2369, right? Change it to a percentage, move it 2 places. It's 23.69% chance. That's the p-value, right? And that's what p-value is, right? Percent chance. That's looking good. See how that's lining up with what a p-value really is? There'd be a 23.69% chance that more than 76%. Is that what we got? Yeah. That's, now don't worry about the more than. We got, yeah, slightly more than 76%. Right? Slightly more than 76% of the 77 voters preferred the Democratic candidate. Yeah, that's the results we got. Right? This right here is our results. So yes, that's totally the interpretation of the p-value in the context of this study. That's exactly what it means. In other words, it's what the p-value is telling us is, because you might say, well, you're wondering if more than 73% of the population, does more than 73% of the population prefer the Democratic candidate? So, well, yeah, we did a survey of 77 people and it came out 76%. That's more than 73. So yeah, we think so. Well, there's a chance you could have just got a lucky sample, right? You only talked to 77 people. What's the chance of that? That's the p-value. There's a 23% chance that you could have just got a lucky sample. Now, that's not really likely, but that's still fairly likely. I mean, that could happen. It's not like getting struck by lightning 2 or 3 times, right? That could happen, right? So that's just too high. That's just not strong evidence. Do you make sense? Now you might, well, how low do you need that p to go? Below 5%. Usually, in our case, we chose 1%. And that's what the significance of means. We wanted the results so strong, so significant, that we wanted less than a 1% chance. And we're about to get to that in part I. That's what the alpha level is. It's how low you wanted the chance to be. You want that p-value to go low, 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 low. Because when it goes low, that means there's a low percent chance that these results were just luck. So we wanted less than a 1% chance luck. That's what the level of significance is. It's how significant you want the results to be. You wanted less than a 1% chance of luck. Well, we got a 23% chance of luck. That was our p-value. That's just too high. That's what we're saying. We're saying if you grabbed another 77 people, and if the average really is 73%, you would have a 23% chance of getting an average that's more than 76% like we got. There's a 23% chance, 23.69% chance of that happening. That's what the p-value means. It's the probability of luck. That's just too high. That's why when the p-value is higher than the alpha, you don't like that. That's considered weak evidence. That's why you stay with H0. That's why we say if the p is low, the normal zone. We want low p. All right, so let's go on now. Why are the other answers wrong? Well, they're crazy. 23% chance of type 1. No, it's not that. 23.69 chance that more than 73%. No. It's the chance of luck. A sample of preferred Democratic candidate is 70. It's not 70. That's not HO. HO is 73. That's why the other ones are wrong. Is that making sense? You're supposed to say if HO is true. This one says if it's really 73, that's HO, and on it goes. That's right. All right, finally, part I. Part I wants us to figure out, interpret the level of significance. So the alpha level of significance. What in the world is that? What in the real world is level of significance? What does it really mean? This is what matters. What does it really mean? Well, it means, it's a probability. It's the probability. Both these are probabilities. It's the probability or percent chance of what? of, how can I put it? Saying, let's see this, of rejecting the null when it is really true. It's the percent chance of rejecting the null when it is really true. So it's similar to the p-value, because the p-value H0 is true. And you're rejecting the null. We call that a type 1 error. We'll get to that later. But it's the percent chance of making a type 1 error. And in a court of law, that'd be like locking up an innocent person. You don't want to do that, right? Right? You know what I mean? Like HO is innocent, like, right? That's what you assume. When an accused person walks into a criminal court, you assume they're innocent, and then you only go with guilty if there's strong evidence, right? Beyond what? Beyond a reasonable doubt. So that's why weak evidence, you stay with HO, right? Like the court of law. So what would it mean if you convict an innocent person? That'd be sad and bad, right? That would be a type 1 error, right? Rejecting HO, you said, no, they're not innocent, but it's really true. They really are innocent. That's what the level of significance is. It's the percent chance of doing that error, of locking up an innocent person, of rejecting the null when it's really true. That's what it is. All right. So, okay, let's go back and see that. So I'm gonna jump down to this one. If the proportion of voters who prefer the Democratic candidate is larger than 73. No. The null is supposed to be true. It's not right. Not larger than 73. If the proportion of voters who prefer the Democratic is 73. Yeah, that's the null. HO true. Remember that right here, right there, HO. That's what the null hypothesis said right from the beginning, way up here. The null hypothesis said HOEP equals 0.73 is, right? And that's what alpha, just like p-value, alpha level says you reject the null when it is really true. So we're saying HO is really true. So we're saying if the population voters really is 73, and then another 77 voters surveyed, then there would be a 1% chance, right? That's the alpha level. That's correct. 1% chance, alpha 101, 1% chance that we would end up falsely concluding that the proportion of voters is larger, right? We rejected HO. We said, no, it's not equal to 0.73, it's larger. That was the H1, right? H1 up here was larger. H1 was larger than 0.73. Yeah, that's exactly it. That is the answer. That's the interpretation of the level of significance in the context of this study. It's not this one because this is, if it's larger. No, it's if H0 is true, if it is 0.73, that we would falsely conclude that it's larger. We reject the null when it's actually equal. When it's actually, it'd be the mistake. It's the chance. There's a 1% chance. We wanted a 1% chance that if it really is 73, we would reject that and choose that by some weird random sample, choose it's larger than 73, right? We wanted a 1. It's the chance that we would mess up the study, just like in a court of law. There might be some evidence brought in that sort of looks like the person did it, but it's not strong. And you end up convicting the person wrongly. That's what we're talking about. Maybe you got a weird sample. You talked to 77 people. They were just kind of more in favor of Democratic candidate than most people. By random luck, you got that sample and made it look like it was more than 73. When in reality, it just is equal to 73. It's not more than 73, but you falsely concluded it's larger than 73. It's not this one. There's a 1% chance that the earth is flat. Obviously, it's silly. There's a 1% chance that the proportion of voters who prefer the candidate is larger. No. It's more complex than that. It's the chance that if the H0 is true, that we would falsely conclude that the H0 is not true. We reject the H0. And so there we go.